Hey, what's up, guys? Today's question is shortest path in a grid with obstacle eliminations. Okay, this is a hard problem. 1293 of LeetCode, and we will be looking at solution for it. It's also problem of the day. I coded it up, and I'm gonna explain to you why exactly what we're doing and why we're gonna use BFS and not DFS. Okay, let us start with it. Okay, so basic question says that there's a grid where obstacles are marked as 1 and empty cells are marked as 0. You have given a k. K is a power to break the obstacle. But once k is exhausted, you cannot break any more obstacles. So somehow you need to find the shortest path to the end goal, which is just the last row and last column. So that is straightforward enough. Okay. One thing clear in these search problems are that that I don't want to use the wrong word, but seems like these are non-deterministic, right? There's no real path. You need to search for something, right? And this is like kind of like an adversarial search, talking from like AI standpoint. Might be wrong in my terminology, but let's start with there. So basically, what we want to do is do something like sort of a backtrack, right? I use my turn and I see, does it work? Does it not? Does it not? Once I weigh this outcome, I can see the choices definitely come down to like a DFS or a BFS. Now, I was trying DFS for it. Did not do much in DFS, but seems like it would be more tricky to implement DFS rather than a BFS. And BFS is also guaranteed kind of to give you like optimal solution. Because in DFS you would need to maintain your path and kind of like a little bit more tricky stuff. So we're gonna do BFS, right? Shortest path. Every edge cost us one, which makes it optimal straight away. What if the edge cost was not one? Then you would use priority queue and you're gonna accumulate the edge weights. This is basically called a uniform cost search. So that's maybe a follow-up question you might be asked or might not be asked. I don't know. But if you are asked that, then all you need to do is make it a priority queue instead of a queue and accumulate all the edge weights. There you have it. Okay. Once that is out of the way, we are going to be looking at this problem now. So basically, the shortest path is go here, here, and down. So let me go down here. Um, Basically, this is the shortest path of length 6, correct. Okay. Straight away, this has like something like a backtracking formula, which we are going to be doing in BFS iteratively. So that's also kind of a good thing to like know in your knowledge stack. Cool. So without wasting any more time, I'm just going to jump into solution now. And keep in mind, I have made this code very nicely written up with variable names. So more or less, it's going to be, you can understand very easily. So in my queue, I'm going to put an array of int where 0 is row, column, and k is the number of obstacles we can break, and 0 is the steps. Cool. This directions is just like for top left, bottom up, down, blah, 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 4 directions, that's all. So visit it, you definitely need visit it because if you visited something, you do not want to visit again. Very tricky thing, you need three things, three columns in it, rows, columns, and k, right? Because say I am here, I travel down here, right? So now when I was here, I was at row column this, and k, whatever k is, say k is 1. When I come like this step, let me change this to a different color. So once I was here, and then when I came here, it would be 0, 0, 0, correct? Now here I have choices to go either here, here, here. Sorry, this is supposed to be one. From here from the top left, I had choice to go to down, right, and not left, not up. It's index out of bounds, right? So suppose we go to the cell that we have visited with the same condition. That means same row, same column, and say k left, same k left, then it's waste. If you do that and you go that way again, you're going to be in Stack Overflow. It's going to just do like same directions again and again repeatedly. That's why you need this visited. Now then I have like a very standard while loop size, for loop for size, and then I have nicely named our variables I, j, k left, count. Count as steps, right? You can say steps, you can say count, whichever one you like. Then I'm saying if I is actually equal to rows minus 1 and j is also equal to columns minus 1, then just return my count, right? If you reached at the last, you can return it. And then now also, this is something you can do at BFS level and not at DFS level, because this is going to be optimal, right? I said BFS with uniform cost is optimal, DFS is not. Makes DFS more tricky. So to make DFS work, what I was thinking is make a list in backtracking and count the list and have like a global variable called min, which just goes to here and check min comma list.count mat.min to kind of achieve it. But we are not doing DFS, we're doing BFS. Anyways, if grid ij equal to 1 and k left equal 0, continue. Basically, if I was here and I'm going here now, my k is not enough left that I can go here. So I'm just gonna say, I just dequeue it right here and then just say, do something else. This is not gonna work. Cool. And then I say, if it is actually greater than 0, then just do minus minus and keep on continuing because we removed this obstacle. Then for every direction, I'm gonna get updated y and x, which is I plus d0 in our direction, which we defined over here. Then we're gonna check out of bounds and visited check. If that's the case, continue. If that is fine, then make our visited true and put this in the queue, right? That's all the logic is. And in the end, return -1. Because if you could not ever find this, there's no solution that exists. So this would work with everything. Here's the code. If you guys want to take a picture or whatever of it. I like the formatting of my code. Really good if you're going to go for interviews to like make it like this. It's kind of very understandable with all these spaces. And the variable names are very important. Do not confuse rows, columns. Do not write M and N here because for some people M is rows, for some people M is columns. You write M and cross N makes your life harder and your interviewer life harder as well. So that is it for this solution. We successfully made a solution for this problem, and for the space complexity, we can see n rows, so rows into columns into k. That's our time complexity as well as space complexity. That makes sense, right? Perfectly. So that would be about this video, and I'll see you guys in the next video. I'm not sure what question I'm going to be doing next. If you have any suggestions, leave them down below.